Hello everyone, I am R.Malathy from the Department of Mathematics. This is our sixth chapter in the first unit, that is probability and random variables. In this chapter we are going to see introduction to moment generating function. First of all, we need to know what is moment generating function. That is, we have to know the generating function, namely moment generating function, and the characteristic function are used to enable a convenient computation of moment of a random variable to estimate effects of x from experimental measurement of moments. As a simple tool to find distribution of sum of random variables to demonstrate the basic results such as central limits theorem. Both these are statistical average of experimental function defined on a random variable. Indeed, they represent transforms a density function of a random variable. An important difference between the characteristic function and the moment generating function is that the characteristic function always exists, whereas the moment generating function exists only if all the moments exist. So in moment generating function we will denote this as a MGF. In this we are having definition, properties, moment generating function. The moment generating function is defined as the expected value of e of tx, where x is a random variable. The property is the function uniquely determine the probability distribution of x if it is exists in a neighborhood of the origin. Here we are having the usefulness is it simplifies the process of finding moments and is instrumental in various statistical applications. So wherever we are going for a graph, that may be a pie chart, bar chart, it may be a curve, wherever we are going to have the, in that case we are going to see the moment. In this moment we are having four types. One is mean, another one is variance, skewness and kurtosis. Calculating of moment using moment generating function. The procedure is by using derivatives of the moment generating function, moment of the random variable can be efficiently calculated. Accuracy is provides an accurate representation of the distribution properties, aiding in statistical analysis. The utilities allows for the determination of key characteristics of random variables in a systematic manner. That meaning is limitation of MGF is a random variable x may have no moments although its MGF exists. A random variable x can have MGF and some or all moments, yet the MGF does not generate the moments. A random variable x can have all or some moments, but MGF does not exist except perhaps at one point. Then we should know characteristic function. The definition of characteristic function is phi of omega is similarly to the moment generating function is given by phi x of omega equal to e of e power I omega x, where I equal to root of minus 1. Then the relationship between the moment generating function and probability distribution. Moment generating function and probability distribution uniquely determines uniquely correspondence. Functional form, here characteristic distributions. These are the major difference between the moment generating function and the probability distribution. Then example of moment generating function is probability and statistic is shows application in illustrating common distributions such as normal, exponential and Poisson distributions. Statistical modeling illustrates the application fitting and comparing the distribution to data for statistical inference used to provide summary statistics and evaluate distribution in predictive models. That is, suppose if you are having discrete data, means we have to go for Poisson. If you are having a continuous data, means we have to go for the normal one. So Poisson, exponential all comes under discrete random variable. Importance of moment generating function in statistical analysis. Crucial for developing parametric models and understanding the characteristic of random variables, enables the estimation of parameters and comparison of various probability distributions, contributes to the testing of statistical hypothesis and evaluation of goodness of fitness. That meaning is, a hypothesis means we have to assume the we have to predict the future after 5 years where we are, where our business would be. So the prediction of happening things is nothing but hypothesis. In this we are having null hypothesis and alternative hypothesis. In null hypothesis we have to mention that by H naught. Alternative hypothesis we have to mention by H1. Limitation and assumption of moment generating function, that is, assume existence, limit applicability, sensitive to moment. So sensitive to moment means we are having 4 types of moments now. First type having tailed, skewness doesn't have any tail, and kurtosis doesn't have any tails, and skewness is having left or right it is not this is not an symmetric one, this is a asymmetric. That meaning is, it may be increasing towards right, it may be decreasing towards left. So these are all the sensitive moments. Conclusion is summarizing the significance and practical application of the moment generating function, reliable to the importance of understanding the function in probability and statistical analysis, highlights the potential advancement and emerging application in statistical modeling and analysis. So those who are going to do PG in MBA HR, in MBA in finance, surely you should know what is skewness, what is kurtosis, what is mean, what is variance, what is statistics. So these are all the terms we are studying in this chapter. So these are all the basic chapters for your future. So wherever you are going to predict the terms, that time you may use this moment generating function. That these are all you will be used in your future technical terms. Thank you.